Okay, let's look at the agenda for a minute. So here we are on 2/28. Okay, it'll be the 7th week, and so we're going to talk this week about presentation software, and the assignment 2 is due this coming Saturday at midnight. Okay, and by presentation software, you know, we mean basically PowerPoint. And so I'm not going to hand out the PowerPoint assignment until next week. And so on the week of 3/6, you know, I'll be handing that out. But it's very simple, and I can tell you what it is. And it's just redo your assignment 1, except in PowerPoint, and make a talk out of it. Okay? And so the thing that you wrote in your first assignment using Word, you want to redo except in PowerPoint. Now there's a big difference, of course, in presenting something with Word and presenting something with PowerPoint. Actually, good presentations don't use words. I mean, or they use words as little as possible. Probably the worst kind of slide is the one that has just lots and lots of text on it. And so you try to get your message across with pictures and with animation, you know, and so forth. And so I'm going to assume you know how to do a PowerPoint presentation. Okay? Anyone here who does not know how to do a PowerPoint presentation? Because if you don't, we'll set up some special, you know, tutoring for you. And so, since most of you know that already, it'll just be a matter of showing it off. And then when you turn this in, and that won't be due, you know, for a while. That'll be assignment 3, and it's not going to be due until, you know, toward the end of March, because we got spring break in there, you know, when we don't do anything. And I'm going to actually call on some of you to present to class. Okay. By this time, the 7th week, I should have covered all of these things here: hardware, software, and internet. Okay, and I have digital technology, hardware, software, and internet. I haven't quite finished internet. Over here in the issues, it's kind of a short presentation, and so I'm going to do that today. Okay, and of course I spent a lot of time on spreadsheets. Okay, working things for you. So your spreadsheet's going to be due this Saturday. Now, I've basically said about all I want to say about spreadsheets. Okay, does anybody have any particular question about Excel spreadsheets? If you feel like you need more example, then my answer to that is, if you have the book, the online book, go to the videos there that explain how to do Excel. They're really very good, and they go little by, you know, if you want, you know, kind of from the beginning, they do that. And so that's one, you know, thing you have. You can also get that on the internet in different places, just, you know, how to do Excel. You can talk to the TA for the course. You can also talk to me, again. Except to me, you got to talk today, because I'm going to a conference tomorrow, and that means there's not going to be any class on Thursday. So on Thursday, you can work on your assignment, you know, even during class. You're welcome to come to class and, you know, work here if you wish. But the TA won't be here during this class, because he has a conflicting class at this time. Okay. So after today, the next class day will be 1 week from today. Okay. Any questions then about the agenda? Let me do this little presentation then about digital life. Okay, so digital life refers to the influence of digital technologies. It's actually been a very big influence. I think I've said this before. I was listening to this TV presentation, and it was about all of the inventions, you know, and gadgets, you know, that have come into play in our lifetime. And they ranked them according to what they thought was most important as a changer of people's lives. So what do you think was the #1 invention of all time? So, yeah. What?
Automobile.
Automobile? No. Light bulb? No. No, not computers.
The wheel.
The wheel? They were talking about inventions that were invented in the late 20th century, I guess. You know. What they ranked as the most life-changing invention was the smartphone. And they said that this has changed people's habits, you know, and how they do business and how they just, you know, interact with one another more than any other invention. Okay. #2 was, in fact, the radio, and the reason that was so important is because it was the basis for, you know, later things like television and the like, but, you know, broadcasting of electromagnetic signals, you know, and the computer was 3rd, and 4th was the hypodermic needle. I mean, before they had the hypodermic needle, medicine was an entirely different thing. So digital life is, you know, the influence of digital technology is not just smartphones, but all. You know. What does the word ubiquitous mean? Yeah, everywhere, you know, all over, you know, computing, you know, everywhere. And so we're in an age of ubiquitous computing. What is this thing right? What's this? What is that? You know, you scan this, right, into your eye. How do you do that? Anytime you see this, you see this on television, you know, quite a bit during news, you know. They'll say, you know, to get more information, you know, they'll click this thing. How many people have used that? Have you used it? Anybody used it? Well, I have to tell you, I haven't used it either. And I should have, you know, because I mean, that's an important thing, you know, nowadays, and we ought to try it out, okay? And so basically, it's like the barcodes, you know, in a grocery store, you know. The computer can read this, and as a result of reading that, that gives it a place on the internet to go. And so it goes there. Ubiquitous computing refers to a culture where digital technologies are embedded in the environment, making interaction with the technologies second nature. Etiquette. What does this picture tell you? So this guy's got a hot date, right? And out in a fancy restaurant, right? And he's talking on his cell phone, right? So have you been in a situation like this? Where the people that you're with are spending more time on their cell phone than they are with the people that they're with. Okay? So etiquette refers to using digital technologies in a manner that's respectful. Of course, there's a lot of press about this, distracting driving. Distracting driving occurs when drivers focus on their cell phone or other distractions rather than on the road. I guess right now there's an ad on TV right now. It says, if you texting takes your eye off the road on an average of 5 seconds. And then it shows somebody doing that and having a wreck, okay? And it says, stop the text, okay, and stop the wrecks, it says. And so that's, I think, an important thing. Another change that's been brought about because of digital technology is a distributed workforce. Does anybody know anyone who works at home? I mean, they're in a company and they work at home. Okay? What do they do at home? They work on a what?
They work for an alarm company.
An alarm company? And they do their work at home. Yeah. Yeah, I've seen that a lot in the computing. That's done a lot. If you're a programmer and you're developing some application, well, you have to be there at work a lot of the time because of meetings and the like. And after all, this programming big jobs is a joint project, and so you have to talk to your coworkers. But a lot of times you can do what you do at home. And professors do a lot of work at home because if it's a day we don't have class, we're just as accessible at home as we are in our office, and because we are usually working on a computer, and we can do our email, we can do our telephone, just as here. A flash mob. A flash mob is a group of people who assemble suddenly in a public place to do something unusual. Yeah, assemble suddenly, okay, in a public place to do something unusual, and then disperse in order to gain attention or to create confusion and sometimes amusement. These groups typically are assembled through the use of cell phone and internet communication. So this is a real big phenomenon nowadays, right? Last summer, right, we had all this disturbances. Okay, well, we talk about the Arab Spring. Right? That was last spring, okay, a year ago. What was the Arab Spring? And that spring is when they had all of the unrest there in these Middle Eastern countries, and then they also had unrest in European countries like England, and riots and the things, and these are all basically caused and abetted, okay, by having this digital technology. It's made things a lot different, and blogging, the individual person actually has a lot of access to the world that the individual person did not have before digital technology. I mean, now, you know, you can start a blog or join a blog and have your voice heard, you know. And, you know, the powers that be cannot filter that out. And so this has really changed the world, you know. And so it's not as easy now for dictators to, you know, keep people under their thumbs, you know, as it used to be. And so it's a real big difference. Repetitive stress injury. Well, I have that, you know. Usually at home, you know, I'm on the computer. This is doing the mouse over here, and I get my shoulder starts hurting. Let's see, and then I had to change hands to do the mouse over here in this hand, you know, and this repetitive stress injury occurs when a particular physical motion is repeated to the point of injury. Anybody here had that problem? And when you talk about carpal tunnel syndrome, right? And there's a lot of cases of that, of people that use the computer all day long. Ergonomics is the study of designing the work environment and positioning computer equipment in a healthy manner. So the monitor has to be at eye level to prevent hunchover. Sufficient indirect lighting to prevent eye strain and glare. Padding in front of a keyboard, wrist alignment, and I have that under my adjustable seat backs, okay. Keyboard at elbow height, okay, for arm and shoulder alignment. Footrests. So these are things that people in computer design look at. Digital addiction. So as you know, we have a really top-rated gaming program here at the University of Houston. We won national, you know, last year in the game design, you know, in the Microsoft Imagine Cup. Not only did we win first place in national, we won second place also. This is in the mobile game design. And won third in the Xbox competition. And the previous year we won second and third. And this year we've already got 3 teams already qualified for the national final. And we hope maybe this year to go to international final. But unfortunately, the people that are in that program are worried about you know, this addiction to games. You know, you've seen that, right? You've seen people that are addicted to games, you know, and this is not an easy thing to deal with, and it's something that you know, the digital gaming basically has caused. And so I don't know what the answer to it is, because the people that do that, they're so into that, you know, and it's such a big thing. It's almost like a drug thing, you know, or it's like drugs or gambling, okay, pornography. It's like exactly the same thing. It's a really unhealthy thing. Okay, so that's the whole thing on digital life. Okay. Does anybody have any comments on digital life? Okay, let me go back then to the internet. And I'd already started talking about the internet. I had talked about, see, I think all of these things I had already talked about, okay? The internet backbone. These are the real fast parts of the internet. They carry lots of data. I have mentioned that this internet backbone was originally created by this ARPA project, okay, back in the late 60s. So today, of course, it's much bigger. I talked about TCP/IP. What is TCP/IP? What does that stand for? TCP/IP. What? What? Transmission? Control. Protocol. Okay. And what does IP stand for? Internet protocol. The packet switching is basically here. Or really, I shouldn't say packet. It's a packaged network. Yeah. And this is TCP is really tells you how to split long messages up into packets. And the internet protocol is what tells you how to get it, moved around the internet. Well, if you have a look at a network, you have these computers on the network, but you have a lot of other kinds of boxes on the network. There are boxes that are called hubs. There are boxes that are called repeaters. There are boxes that are called gateways. There are boxes that are called routers. And there are boxes that are called servers. And then there are, of course, just normal computers. And the purpose of networks is to connect the computers together. But these other boxes are needed in order to hook computers together in networks. So, what's a hub? You go down to Fry's and buy a hub. Okay. What is it? What does it look like? Yeah. Yeah, exactly. The hub is a little small box. Yeah. And over here, it'll have a whole bunch of these little, looks like telephone jacks, right? And then, of course, it has a looks to the wall again. Are these telephone jacks? No. What are they? What are these little places you hook things into? Okay. What? I can't hear you. Okay, no. These are Ethernet ports, okay? Excuse me. Or Ethernet connections, let's say. And so I have one right here. I mean, my computer here is hooked into the Ethernet. I'm not using it right now, so I'm going to unhook it, And, they look like this. And this is a wired connection, okay, between computers. And so it hooks in to your, laptop or your desktop. And the other end of it, okay, and in this case it goes into the wall, okay, and hooks into the wall, okay. If you had several computers, let's say at your house, you had several computers, computer 1, computer 2, computer 3, okay. Then basically you can hook these computers together in a network, okay, by running Ethernet cable from the computer to a hub, okay. And then basically these computers are all networked together. That is, information can flow from C1 to C2 or C3, okay, and from C2 to C1, okay, and so forth. Now that's what a hub is, okay. What's a repeater? Well, in Ethernet connections, about the longest connection you can have is about 40 feet. And so you can get these long Ethernet connectors, right? But if they're over 40 feet, the power is power loss, okay, due to the length, and they don't work well. So for long connections, you have to put in a box called a repeater. And all it does is it just basically boosts the power back up. It's basically an amplifier that you have to put into the circuit in order to have enough power so that it doesn't die out, okay. And so if you have a really long connection, several hundred feet, you have to have a bunch of repeaters if you want to directly connect. What's a gateway? Well, a gateway is when you have a network. You have to say two networks here, okay. You've got network 1 over here and network 2 over here. And let's say these networks already exist, okay. And so you got a bunch of computers over here hooked together somehow. And then you've got computers over here hooked together somehow. And then basically you want to combine these two networks into one, okay. Then basically what you do is you get a gateway, okay? And then this gateway somehow hooks into this network and then hooks into this network, okay? And so then you get a bigger network. So we have a lot of that then going on. Now, what is a router? Did I mention DNS? So here is, I guess, so I talked about Internet Backbone, talked about TCP/IP. I talked about Internet Service Provider. That's just a company that will hook you onto the Internet. I talked about client server, peer-to-peer. I'm going to mention those again though. Here's router and domain name service. What is domain name service? Here's a router. Yeah. So a router is a network device that manages network traffic by evaluating messages and routing them over the fastest path to their destination. Although routers play a crucial role on the internet backbone, they are also used to smaller networks. Routers are used in business home networks to allow computers on the network to communicate. Domain name service. The domain name service maintains a database of all domain names and IP addresses used on the internet and acts like a phone book, supplying information to the internet nodes and routers working to get data packets to their destination. So in the computer science department, we've got a number of computers that are on the internet, and I don't know how many computers we have in our department that are hooked to the internet, but quite a few, a couple of hundred maybe. And there would be if you go into one of these computer labs, like this one here, this computer lab here, each one of these computers will have an internet address of something like, I think they call these computers Valkyrie. So it'll be something like V1. Okay, they may actually say Valkyrie 1. Okay, but V1, and these computers are in a lab here, or an organization called TLC squared. TLCC it's called. Okay. And then that is part of UH. Okay. And that's in the EDU. Okay. So if you're on one of these machines here, your internet address would be something like this. Okay. Valkyrie 1, okay, in TLCC, okay, which is Texas Learning and Compute Laboratory Center, Texas Learning and Compute Center, U of H, EDU. Okay. Now that has to be converted into actual internet address, which is all numerical. And so this EDU will have some numerical equivalent, I think like 127. And UH will have some equivalent, okay, say 69. Okay. TLCC will have something. Okay. 80. Right. And V1, there's 48 of these computers in here, be starting with, say you'll have number 5 or something. Okay? So the actual when you actually get when you use one of these computers and hook up to the internet to some other computer, you have to know this address here of your computer, and then you have to know the similar address of the computer you're trying to connect to. Okay? So the process of doing that is the domain name service. And the way it works is like this. The biggest part of this is something. It'd be something dot edu, or it'll be something dot gov. Or it'll be something dot com, right? or it'll be something 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 .org. Okay, those are the main ones. Okay, so if the internet address ends in edu, it means it's an educational institution, right? gov, it's a government institution. Com, it's a commercial institution, and org, it's usually a not-for-profit organization. Okay? If it's outside the United States, it'll actually have an extra thing. Here, like Japan, will have a JP hooked onto it. Okay, and other countries, will have. Great Britain is UK, the United Kingdom. Yeah. France, I forgot FN. FR, I think. Italy is, IT. So what happens is there'll be a set of computers around the world that will handle this .edu. And so all the EDUs on the internet, okay, will be handled by certain computers. Okay, certain computers around the world will be selected. Okay, and it may be just one computer for a country, handles all the EDUs for that country, or big country, like the United States, there'll be several of them. Okay, and so this computer right here handles some of the EDUs. This handles other EDUs. Okay, Okay. So if your computer is somewhere, okay, and you're hooked in, say, over here, and you want to have access to some EDU somewhere, then the domain name service, okay, your computer will direct you to the local domain name server for EDU. Okay. And if you're trying to get, say, U of H EDU, then maybe this one right here is the one that handles UH EDU, and so your message will be forwarded to this EDU server, and it will say which computer or computers handles UH.edu, and so it'll come over here to this, okay, and then that computer will handle UH, and then there'll be other computers that handle TLC squared, and so if you want to get TLC squared, there'll be one computer in that cabinet over there, okay, that handles TLU squared, okay, and then that gives you the Valkyries, okay. Similarly for the comms and so forth. So the domain names system, okay, maintains a database of all domain names and IP addresses used on the internet. Acts like a phone book, supplying information to internet nodes and routers that are working to get data packets to their destination. So a port, in a computer network context, a port is an address used by clients and servers that is associated with a specific service. So there are different types of servers on the internet. So there are web servers, right? And a web server serves web pages. I mean, you think of it as a store, with a big sign on it. Web pages available. And this web server is just a program. And so this program runs on this web server computer. And so it communicates, you know, with others via some port, okay? So these ports have numbers. And, you know, the port 1, 2. And each different port is for a different type of protocol. And so, for instance, Telnet, the Telnet protocol, its port number is 22. Okay. Then a secured Telnet, SSC, is 23, okay, and so forth. And so these web servers have these ports. So if you're just a computer over here and you want to hook to a particular web server, you have to give, you know, the name of this web server, you know, UHEDU, you know, something again. That's a CS again. And if you then want that, so it will go to a particular computer, which is a web server, okay? And if you send this over in the HTTP protocol, then basically it will direct your message to a particular port that handles the HTTP protocol. Your computer will also be assigned a port, but you'll be the client to the server, okay? And your port will be just assigned on the spot when you make a connection. It'll be a really high number, like 20,000 and something, okay? And then once you establish this connection, then your port 20,000 will be connected to this web service port, okay, for internet, for web, sorry, for HTTP. Just as the post office sorts mail by zip code, internet servers sort data packets by port number to deliver them to the intended service. Voice over IP refers to technologies that support voice communications using internet protocol over data networks. You've heard about the jack, right? So there's ads all the time on TV about the jack, right? It says buy a jack, okay? And that becomes your telephone, okay? And what the jack is a little device that hooks into your computer, and it's a like a wall switch to a telephone. Okay? And then this jack they'll lease to you for $19 a year, right? And then all you have to do is get a telephone that'll hook into the jack, okay? And you know, pick it up and you dial a number, okay? And then basically you're using the internet for your telephone service. $19 a year. Okay? That's a pretty cheap telephone bill, right? Does anybody have that here? You know, I mean, if you go to AT&T, how much did it cost you for a telephone? It's a simple telephone, regular telephone. Well, it costs you a lot more than $19 a year. Okay? It'll cost you more than $19 a month, okay, for a normal telephone. Okay? So this is really, really cheap, and people buy it. And then that's actually, this is the technology, voice over IP. Okay? The only problem is it's not very good. It's a really what you call poor quality service. You talk to somebody and you start breaking up. You know. It drops the connection. You know. You have to dial them back. You know. Talk a little while, drops the connection. Okay, and so if it were just reliable, you know, it would be a really good thing. But I guess for $19 a year, you can't complain too much, I guess. Internet 2 is a research and development consortium led by more than 200 U.S. universities and supported by partnerships with industry and government to develop and deploy advanced network applications and technologies for tomorrow's internet. Well, University of Houston, of course, is on internet too. We are a participant. In my office here in this building, I have a connection, a wall connection, okay, it's an Ethernet connection to the internet. I also have one internet too, which is much faster. Why is internet 2 a research? What research are they doing on internet 2? And development, it's a research and development consortium. What are they researching? What are they developing? Well, they're developing faster ways, you know, of doing things. A lot of the present protocols that you use on the internet, such as, say, FTP, File Transmission Protocol, or HTTP, have timings involved in them, okay? And so Internet 2 is a very fast network, and in some cases too fast, okay, for the timings involved in the protocols. And so they have to develop, you know, equivalent protocols, newer ones, okay, for these faster environments. When will Internet 2 go public and have the general public can use Internet 2? Well, I don't know. I mean, here at UH, we had the Internet back in right around 1980, in the early 80s, okay? It's when basically the computer science department here got it on the Internet, okay? And so we were doing Internet applications and doing Internet stuff here. The Internet did not go public until 1994. 1994 is when the .com, Internet URLs were allowed. Web technologies, okay. The web, short for the World Wide Web, is an internet service that provides convenient access to information and services through hyperlinks. In this section, a web browser. What is a web browser? Where was this World Wide Web? Who invented World Wide Web? See, that's different from the internet. What? No, it wasn't the military. It wasn't even the U.S. actually. I mean, the original internet had 3 applications, and I mentioned them before. Does anybody remember what the 3 applications of the internet were? See, the internet was the late 60s, okay? And remember, this was sponsored by ARPA, the Advanced Research Projects Administration, and this was military. And ARPA nowadays is called what? DARPA, the Defense Advanced Research Project Administration. And they wanted to hook their computers, their main computers, together. And what they wanted was 3 applications. They wanted email. They wanted file transfer. And they wanted remote logon. That's all they wanted, those 3 things. And that's all they basically had. They didn't have the ability to bring up a web page. Okay? That wasn't even thought of back in these days. Okay? So who thought up World Wide Web and web pages? Well, it was actually an international organization based over in Switzerland. And this place is called CERN. C-E-R-N. And what CERN is, it's a high energy physics research laboratory. In physics, at high energy physics, there's something called a cyclotron. And what a cyclotron is it's a ring where they have electrons spinning around in this ring. And they get electrons spinning around in this ring real fast, you know. And they try to get these electrons to bump into atoms, okay? And then when these electrons bump into atoms, they split the atom apart, okay? And that way, this is how they find out what the subparts of an atom are. And the bigger the ring, okay, and the higher acceleration, okay, gives you better control over this. So the first cyclotrons were just about this big, you know. And then they got bigger ones and bigger ones and bigger ones. Okay. The largest cyclotron in the world is over at CERN, and it runs under the mountains of Switzerland, okay, and all around, and it's many miles around. Okay. And there, then they had a bunch of physicists, okay, and these physicists were interested in the pictures that are caused by these atomic interactions. So they came up with, this lab came up with HTTP. So the hypertext transmission protocol. And so here, this was a new protocol where computers could connect and see web pages, basically. And for a long time, it was only physicists that could do this HTTP, you know. And then there was a university one that was created at University of Illinois called Mozilla, okay? And so here at U of H, we were using Mozilla, you know, back in the 80s also. And then this went public, you know, when the internet went public, okay, then this World Wide Web went public, you know, with it. The web, short for the World Wide Web, is an internet service that provides convenient access to information through hyperlinks. So what's a hyperlink? And this was part of HTTP when it was invented at CERN. And basically, you know, you'll have some text that you're reading, and if there's a web page, if this text contains a word, and there's a different web page just for that word, or that better explains that word, you can click on that word, you know, and then a new web page comes up. And so you can follow these hyperlinks. So a web server is a program that runs on a computer that basically serves up the web pages, okay, for a particular organization. A URL stands for what? What does URL mean? So here's a bunch of acronyms: URL, HTML, XML, CSS. Well, let's just go look at them. So URL, Uniform Resource Locator, URL, Uniform Resource Locator, more commonly called a URL, acts as a web page address, incorporating the domain name of the web server and the location of the web page file on the server. The Internet Corporation for Assigned Names and Numbers, ICANN, is responsible for managing URLs and IP addresses. ICANN authorizes businesses known as accredited registrars to register new domain names. There's an attempt going on right now to take over this internationally. There's an organization that's part of the UN that's having a meeting this next week, I think it is, in Switzerland. And basically they want to be the people who assign these things. This has pretty much been something that went on in the United States. Okay? The United States had control of this. Okay, this ICANN. Okay, and now the international community is saying, well, you know, we want control of this internationally. Well, no problem. So HTML, hypertext markup language, okay, is the primary markup language used to specify the formatting of a web page. Here's what HTML looks like here. So it's got all of these little things that are, see, look like these greater than, less than signs, okay, and this says HTML, okay. So that is the first thing in an HTML file. Okay? Basically tells you it's an HTML file. Here this says head, and then down here this says slash head. Okay? And HTML is just full of these things. Okay? And if it doesn't have a slash in it, it's the beginning of something. And if it does have a slash in it, it's the end of something. Okay? So it says, here is the heading of my web page, this web page, okay? And this is the end of the heading. Okay? So everything between head and slash head is the heading. And here this says title, okay? And so there will be a slash title, okay, somewhere else. It doesn't show it here. And so it's got all the title stuff in it, okay? And it contains, you know, hyperlinks in the title, maybe. XML, extensible markup language, provides a method for describing and classifying internet delivered data, so it's easier to organize and manage. XML code used to catalog a collection of CDs. Here's XML. Well, you can't see it, okay? But it's like HTML. It's just an extension of HTML. CSS, cascading style sheets, or CSS, allows easy application of visual layouts for fonts, colors, layouts, and other pages. So basically, there are people that design web pages, right? And so if you want to be a web designer, a web page designer, the first thing you have to learn is HTML. Okay, that's pretty easy to learn, and you can actually design a page, you know, by just typing a Word document, you know, with all this HTML in the beginning and ends of things. See? But there's fancier ways of doing it, easier ways of doing it, okay? And so there's software that allows you to design these web pages with these cascading style sheets. Web development software allows developers to create web pages more easily using a word processing style environment and automating complex coding activity. Okay. WYSIWYG, W-Y-S-I-W-Y-G, pronounced WYSIWYG, implies that the web page you design with the web development service will look the same as when published on the web. Okay. What you see, WYSIWYG means what you see is what you get. A cookie, sometimes called an HTTP cookie, a small text file placed on a user's computer by a web server in order to identify the user whenever he or she returns to visit a website. Actually, all of the cookies on your computer are in a directory that says cookies. Okay? And you just have to go up to the C:, level and trace down. You can actually find the cookies on your computer. Maybe we should do that. So if I want to see the cookies, so I go down here. This, here is Windows Explorer. I'm going to click on Windows Explorer. And Windows Explorer allows you to look around on your disk, your local disk, and see what's there. So there are different parts to it, but down here is something called Local Disk C, and if you double click on that, that's the highest level of organization on your disk. Okay. So this highest level here has various things on it. Okay. It has program files. Okay. Windows, Windows old, Windows tablet. Okay. Let's click on Windows. Okay. Okay. Here's has all these things in it. Okay. So these are the various parts then of the Windows operating system. Okay. You don't want to mess with this. You don't want to change these things. Okay. I mean, if you go in here and try to delete one of these files, okay, you really want to mess things up badly. However, it won't let you do it unless you have administrative privileges. Okay. So you go back to local disk. You've got Windows. You've got Windows old. Okay. Users. You've got program files here. I think cookies though is in Windows somewhere. This, by the way, it depends on your operating system. Okay. And here I've got this is Vista. Okay. I don't think it's ever been upgraded to Windows 7. Okay. And I think it'll be down here. Rather than mess around looking for it, there's a better way of doing this. Okay. You can come over here, and you can do a search. Okay. And so you can just type in here cookies. Alas, I'm out of time. I'm out of time here. So remind me next week to locate cookies for you. Okay. Anybody have any questions? Okay, remember there's no class on Thursday, so I'll see you next Tuesday.